purpose of this video is to show you how to construct an expanded frequency distribution for a data set, a number data set. Here's our data set. The sample data lists prices in dollars of 30 devices, 30 GPS navigating devices. In a previous video, we made the frequency distribution table for this data set, and now we'd like to expand that frequency distribution table to include midpoints, relative frequencies, cumulative frequencies, and percentage cumulative frequencies. In the comments section of this video, I'll put a link to that previous video. So we're looking at the frequency distribution table for this data set. You can tell it has 7 different classes. What we'd like to do is find the midpoint of each class. To do that, it's quite simple. We're going to use the midpoint formula, and of course that's just going to be given by this formula here, upper class limit plus lower class limit divided by 2. So for the first class, we've got class limits of 59 and 114. So to find that class midpoint, we're doing 59 plus 114 divided by 2. And when we calculate that, that gives us 86.5. Now we don't want to round that midpoint, because if we do, we won't have the midpoint anymore. So for the next class now, we can find another midpoint, and we can of course just keep on using the same formula, just sum up the class limits and divide by 2. Or we can just add the class width to each one of these midpoint numbers to get the next midpoint. So recall that the class width is the distance between any 2 consecutive lower class limits or upper class limits. And remember, we found already in a previous video that class width is 56. So we can go ahead and find that now. It's 227, subtract off 171. I've got 2 consecutive lower class limits here. I subtract the 2, and I'm going to find out, hey, I've got a class width of 56. So to get the next midpoint, I simply need to add 56, the class width, to this class midpoint here, the class midpoint I just found. So let's do that now. Midpoints are all separated by a distance of class width. Therefore, to find class midpoints, we just need to use the midpoint formula on the first class as we did here, and then just add class width to that number to get the next class width. So we'll go ahead and keep on finding the class midpoints here just by adding 56 to the previous midpoint. That will give us the value for the next midpoint. Keep on adding 56, the class width, to your midpoints to get the next midpoint, and keep on doing that until you've got midpoints for all 7 classes. And just as a check, we want to make sure that each one of these numbers is indeed living inside of each one of these intervals. So that looks like that's fine. Let's go ahead and fill out this next column, the relative frequency column. The relative frequency of a class is just the percentage of the data that belongs to that class. So to find the relative frequency for a single class, we just need to use this formula here, take the class frequency and divide by the sample size. So if you take a look at the data set, it looks like the sample size is 30. There's 30 entries in the sample. So that'll inform us how to find relative frequency for each class. So let's go ahead and do that now. The first class has a relative frequency of 5, the frequency of that class divided by 30, and that's about 17% or 0.17. The next class has a frequency of 8, so the relative frequency would then be 8 divided by the sample size, which is about 27%. The next class has a frequency of 6, so 6 over 30 will be its relative frequency, or about 20%. So we're going to keep on using the formula for relative frequency until we've got all of our relative frequency numbers. Let's go ahead and do that now. Okay, we've got all the relative frequencies, and let's see if we can understand the meaning of each one of those numbers. The relative frequency of the first class is 0.17, or about 17%. What this means is that there are 17% of the data. 17% of the data values belong to this class. 17% of the data are prices between $59 and $114. The relative frequency of the next class is 27%, so that means that about 27% of the data values belong to this interval class, or in other words, 27% of the data are GPS prices $115 between and including $115 and $117. So the relative frequency, that's just the percentage of the data that belongs to that particular class. Let's go ahead and find cumulative frequencies, the next column. So the cumulative frequency of a class, that's just the sum of the frequency for that class and all of the previous classes. So in the first interval class, the frequency is 5. There are no other classes before that, so the cumulative frequency for that class is just 5. To find the cumulative frequency for the second class, we're going to sum up the frequency for that class, 8, and the frequency for the previous classes. So it's just going to be nothing more than 5 plus 8, or 13. The frequency of the next class is 6, so the cumulative frequency will be 13 plus 6, or 19. The frequency of the next class is a 5, so that means the cumulative frequency will be 19 plus 5, which gives us 24. So notice what I'm doing. I'm taking the sum from the previous cumulative frequency, and I'm just adding to that the frequency of that class. That'll give me the next cumulative frequency. And a couple things that we should note: the last class should have a cumulative frequency equal to the sample size. Another thing that we should have over here for the relative frequency column, we need that the sum of the relative frequencies ought to equal 1 or 100%. You can be a little bit over or a little bit under here, but you need to be careful about how you do the rounding. Let's try to make sense of what the cumulative frequency numbers mean. So I'm noticing that the cumulative frequency of the second class is 13. So this means that there are 13 devices in the sample. This means there are 13 devices in the sample that are priced at $170 or less. The next class has a cumulative frequency of 19. This means that there are 19 devices in the sample that are priced at $226 or less. There's 24 devices in the sample priced at $282 or less, 26 devices in the sample priced at $338 or less, and so on. So that when we get to the last class, we've got all the... Okay, let's do our percentage frequency column. The percentage frequency column, to get those numbers, we just need to take our cumulative frequency and divide that by the sample size. So we'll do that for each one of our classes. Okay, so you can see what we've done here. We've just taken our cumulative frequencies and made percentages out of them. So I've noticed that the percentage cumulative frequency of the second interval class is 43%. This means that 43% of the GPS prices in the data are devices that are priced at $170 or less. 63% of the prices in the sample are $226 or less, and so on. So there you have it. That's how you make an expanded frequency table. The first thing you need to do is, of course, obtain these first two columns, and to do that you need to make a frequency distribution for the data. That's something that I did in a previous video. I'll go ahead and put a link to that video in the comments section of this video.